what makes this LAB fermentation, I think, so interesting is, especially with vegetable fermentation, you can get almost any vegetable to be a lactic acid ferment. If you cut it up, put it under water, and add the right amount of salt and keep it anaerobic, i.e. keep air from touching it, most vegetables will have some lactic acid bacteria naturally on them. We just have to cultivate them.
Welcome to Longevity by Design, a podcast designed to give individuals access to the leading scientific information in the field of longevity. The ability to add years to your life and life to your years needs no opinion. Join us as we ask science to take the wheel. In each episode, Dr. Gil Blander joins a co-host and an industry expert in the field of longevity, shining a light and getting the answers to the key question: how can we live a longer, healthier life?
Hello, I'm Dr. Gil Blander. Welcome to Longevity by Design, how to live a longer, healthier life. We are produced by Inside Tracker, your science-based guide to optimize your body from the inside out. Our guests today are Dr. Jacob Allen and Dr. Mike Miller. We'll discuss their work on health, gut microbiota, and exercise physiology. Dr. Allen received his bachelor and master degree in exercise physiology from the University of North Carolina at Chapel Hill, and his PhD in kinesiology from the University of Illinois Urbana-Champaign. Dr. Allen followed his PhD by completing a 3-year postdoctoral program in microbiology at the Nationwide Children's Hospital in Columbus, Ohio. Dr. Allen's research program concentrates on specific environmental intervention and condition. Dr. Miller received a BSc in environmental toxicology at the University of California, Davis, and PhD from Michigan State University in food science and environmental toxicology. Dr. Miller continued his education as a postdoctoral scientist at North Carolina State University. In January of 2006, Dr. Miller joined the University of Illinois as an assistant professor. So welcome, and I'm very excited to discuss today with you your research. And before we start with that, let's learn a bit about yourself, and specifically, what made you to become a scientist? Why have you decided to be a scientist and not doing any other occupation?
Yeah, that's a great question, actually. I think it probably ties back to early in life. I really had an innate interest in biology and how things worked. And it was either between engineering or biology. I liked both of them. But ultimately, it came down to wanting to know the answers to questions and how things functioned. And I got pulled into biology. I think actually started my bachelor's at a college on the coast of North Carolina, UNC Wilmington. I became very interested in marine biology. So that's kind of how I started, because we were close to the water. But then I realized that I grew an interest in health and trying to understand, why we have this increase in chronic disease in our country and across the world, and trying to understand the origins of that. So then I transferred to UNC Chapel Hill and wanted to focus on what I think is one of the best interventions for health, which is exercise, and started to think about what is the biology behind exercise and why that's important. So I did my bachelor's and master's at Chapel Hill, focused on exercise physiology, and then came to University of Illinois and focused in on the immune system, and particularly how exercise can impact immunology as well as basic metabolism and physiology. And that led me to study the microbiome, because we know that the microbes in the gut have a very intricate relationship with the immune system. And so then I started looking more into microbes and their importance, and really led me to what my career is now, which is focused in on all of the really unique and intricate things that the microbes in our gut, and we'll talk about today, also in our food, can do to our health. And we're very intrigued by what we think are very important metabolic properties of food, and how they can drive some really important changes in our physiology. And so that's kind of where we're at today, and probably what we'll talk a lot about.
Cool. So from exercise to microbes.
Yeah, so we kind of all over the path for me. But actually, I think it makes it fun, and kind of having those unique perspectives from different aspects of science.
Absolutely.
I think personally has helped my creativity in science and helped drive a lot of what I think is cool work that we do.
Excellent. Dr. Miller?
I think there's some similar themes for me as well, but I think when I think back, so it's been a little longer for me than for Dr. Allen, but I was an undergrad at UC Davis. I was painting dorm rooms and having other really kind of, paycheck type jobs, but nothing that was really advancing my career. I was a science major. I liked science, but I didn't know what that meant exactly. But my department had just hired a new faculty member, and he was at like a welcome pizza party thing that I went to. I just happened to be sitting next to him. And he's like, yeah, I'm looking for, a couple undergrads who work in a lab if you're up for it. I'm like, sure, I got nothing but, I could quit this lame job in a second for something better. And working in his lab was really a transformational experience for me. It really exposed me to what research is like, and being able to get curious about things and be able to answer, develop studies to answer your questions. It just was really a world that was not clear to me, or I was aware of until that experience. And so I was very it's unfortunate more of undergrads don't get to have that kind of experience. I think we would have a lot more scientists in the U.S. if we could. But then since that time, I've just kind of followed my passions, and so I ended up going from studying the AH receptor, which we might talk about later today, to studying fungal genetics in Michigan State, and that's just because the advisor I met there and the project just sounded really interesting. I had no idea what he was talking about, but I'm like, this sounds great, let's do it. I ended up doing a postdoc at NC State where I studied lactic acid bacteria, which has become my thing. But I've always just followed my projects that sounded, just to strike my fancy. Like, never very strategic. It was always very passion focused. And I tell students this all the time, but if you follow what you're really interested in, you'll be really good at it, and that'll open more doors for you, rather than try to think of, it'd be more strategic if I did this. If that's fine, as long as you're passionate about it. I was passionate about the science, and I wanted to do something that was interesting to me. And so as long as I followed that, it's worked out great for me. So.
Excellent. And it's not often to see two PIs working together. So I think that usually in science you are more like a lonely wolf, and it's nice to see a couple of scientists working together. Maybe we'll get into that later, but we have a tight schedule. So let's go and deep dive into science. And let's start with the question about what you are working on, and specifically fermentation. So can you explain to our audience what is fermentation? What is in a simple ways that
Yes.
not a scientist can understand?
So the fermentation is fascinating because it has many definitions and depends on who you talk to. Biochemists use a very particular definition that's not what food scientists use. So from a food perspective, fermentation is any time we use microorganisms to act on a food product and to generate something new.
Yeah.
And so the traditional definition would be more like anaerobic metabolism. But there's actually many fermentations, food fermentations, that are nothing to do with anaerobic, such as vinegar, soy sauce, many other fermentations have no any connection to that. They're just microbes working on substrates to create new food products. Mm-hmm. And so that's the definition we roll with in food science for food fermentation.
Okay, and what microbes are involved in fermentation?
Well, there are many, but the key ones are yeast. So Saccharomyces cerevisiae, which I think people are very familiar with, beer, wine, bread, many other products. Even lots of enzymes come from yeast. And then lactic acid bacteria, which is more my specialty, is another important group. I think these are involved in making cheese, yogurt, sauerkraut, kimchi. Many products have yeast and lactic acid bacteria, like kombucha, kefir, sourdough bread. So those two are really the workhorses. There are exceptions. There's like mold-ripened cheeses that have penicillium and lactic acid bacteria, for example, or Swiss cheese that might have propionibacterium and lactic acid bacteria. But you find those two groups, the lactic acid bacteria and yeast, are involved in the vast majority.
And those microbes are getting naturally to the food item, or we are inducing it by adding some bacteria or yeast?
All things. So it depends on the type of food product. Most of the dairy products that you're familiar with are fermented with starter cultures. So they work with a company that grow up these cultures in large amounts, sell them to the producer, and they can add that and have a very defined community of bacteria that they're adding or yeast that they're adding to their food product and get a very consistent product in terms of time it takes to do the fermentation, in terms of the quality, the sensory qualities, all these things. So that's with starter cultures, but you can also do spontaneous fermentations. So many vegetable fermentations are spontaneous. So you just, like sauerkraut, you just add salt, get to salt concentrations around 3%. That'll select for the lactic acid bacteria naturally present on the cabbage leaves to do the fermentation and make sauerkraut for you. So there's some fermentations are like that. In some textbooks you'll see it called natural. I like spontaneous better. Natural has like that's a loaded word for me, and so students always think that's better because it's natural, and that's not what the implied. It's spontaneous.
Yeah.
Or wild. Sometimes I use wild as a counter to the natural vibe, but it's totally safe process for things like sauerkraut, appropriate for certain kinds of products. And then backslopping is another possibility, and things like sourdough have a component that's like that. Even chocolate fermentation has a backslopping component where they kind of use part of the previous batch to start the next one. And it's kind of a keep it rolling kind of strategy.
And when we started to do it, how many years ago have we humans started to?
Thousands and thousands of years ago.
Yeah.
It depends on which food product and which ones we're talking about, but things like bread go back 5,000 years or more.
So that was spontaneous, I assume. It's not like someone understood that there is a bacteria.
Well, this is certainly we were we didn't see yeast or bacteria on a microscope until 400 years ago or so, and then it wasn't until Pasteur, which is not Napoleon times, that we learned that these are living or things that you're seeing on the microscope. So yes, for thousands of years we were doing fermentations without knowing what bacteria were or how. But there was skill, and that's why trades like bakers, brewers, some of these last names are trade names because these people learned this skill. They maybe didn't understand the science of how the bread making worked exactly, but they knew the trick. So if they did it this way, it worked, and they had a particular skill set, whether it's to brewing, baking, or whatever.
Can I add on to that?
Yeah,
a little bit?
of course.
There's still debate as to what our first evidence of fermentation really is, and the strongest evidence I've seen, as far as the earliest we can tell, is actually in this part of Sweden, where they found these ancient sites, probably about 8,000 to 9,000 years ago, so about 7,000 BC roundabout, where they found these gutters. They call them gutters, but they're essentially these underground fermentation tanks. And there they found these evidence of seal hide. And within the seal hide, they found evidence of fish bones. But what was really interesting about the fish bones is that they showed acid decay. And so what they think is that these individuals back then actually wrapped the fish in seal hide to keep it anaerobic and allowed the fish to ferment underground. And this is what's interesting about this is actually a cold fermentation, and what we think is it actually doesn't need salt, the addition of salt. So it would be a very intuitive process in a way, and potentially one of the first pieces of evidence that we were fermenting meat as well, which is something we haven't talked about. It is possible to ferment meat. The taste is interesting and not necessarily liked by everybody, but it is possible, and lactic acid fermentation is certainly possible.
And it's a good way to maintain the meat for longer.
Yeah, absolutely.
When you don't have refrigerator.
And that's the benefit of really a lot of these fermentation practices is that they keep foods for a much longer period of time without refrigeration. And we did not have refrigeration until,
100 years ago.
Exactly.
Like that, So
I think, certainly as society have a hard time understanding what things are like without the technology we enjoy today.
Yeah, exactly.
And so whether it's refrigeration or understanding what microbes are or having a microscope, pH meters, all these things, or even having food ingredients that we could add and stuff. Yeah, it's an interesting perspective.
No, it is, and it's interesting to know that like 9,000 years ago or more, we used to do that. So it's pretty
Yeah.
long term, and we assume that we got a lot of experience, some of us, how
Yeah.
to do it.
And that's what we have evidence for.
Yeah.
I mean, there is argument in the field that
Yeah.
we were doing it before that, but that's up for debate. We'll talk about some of the health
Yeah.
benefits and the evidence
Yeah.
there too as well.
So my next question is about probiotics and the live culture. So what is the difference between that?
Yeah, so that's a great question. I get that a lot. So probiotics have a very precise definition. These are live microorganisms that provide health, that when provided at a suitable dose, provide a health benefit. And so there's several parts of that, but this means this particular strain has been tested in people and shown to have, when live and consumed at a certain amount, provides a documented health benefit that they can measure.
Yeah.
Right? So that is a very precise term.
Yeah.
Live cultures, many foods have live cultures, such as yogurt, kimchi, have a lot of microorganisms associated with it. And so does that mean those organisms don't have a probiotic benefit? Don't know, because nobody's tested those individual strains in that particular product. Because it's a wild fermentation or a spontaneous fermentation, it's always different strains. Many of the traits that we see in probiotics, a lot of them are very unique to strains. So it's a kind of a misnomer. You shouldn't confuse the two. Probiotics are things that have documented clinical evidence.
Yeah.
Live cultures, on the other hand, you're eating live microorganisms. Oftentimes you're eating things that include their metabolites, which we'll talk about. Not all fermented foods have live cultures, but many do. Things like chocolate or bread, for example, don't. They're all killed off in the process. But things like yogurt and cheese, kimchi, sauerkraut, they'll still have plenty of live microorganisms. I'll pass to Jacob, but there's been a lot of evidence about health benefits of live cultures and how those could be also beneficial. And so but I think the important part to consider is that is probiotics are defined, they've been tested specifically.
Yeah.
Yep.
Whereas live cultures is more of a less specific entity that still might have a health benefit, but it's a little harder to meet the documentation that
So it's all about the claim, I assume, the claim of the food company. In a probiotic, it should be much specific. Live culture is more broad. That's
Yes,
okay.
but doesn't mean it's not good. It's just
No, I
different.
understand,
Yeah.
but it's they have the regulation, the USDA, so they need to
Exactly.
follow that.
Yeah.
And so, what are the benefits of consuming fermented food, if at all?
That's a great question. I think that we think there are benefits, but I think we have to go back to the kind of the original question that Mike answered, which is what type of fermentation are we talking about first?
Yeah.
There's such a broad set of foods that we have to be specific about this. And I think that's what we need to do moving forward as scientists and practitioners. So a lot of the research we're focused in on is what we call lactofermentation. So it's specifically fermentation driven by lactic acid bacteria. So the end product for most of these bacteria is lactic acid, but as we'll learn, they produce other metabolites as well. But that differs from things like alcohol fermentation, right? Which is a completely different type of fermentation, mostly done by yeast, as well as different than acetic acid fermentation, which produces a vinegar end product. And there's others as well, but those are the three primaries. We're mostly focused on lactic acid fermentation, and we think, at least my opinion, and Mike I think would agree, that a lot of the benefits of fermented foods are within this realm for a couple of particular reasons. But there is growing evidence that ingestion of fermented food is beneficial. There's some NHANES data, which is essentially this large database where, again, this is cross-sectional, but going back and looking at fermented food intake in these individuals is the higher the fermented food intake, the lower of these particular markers that are associated with metabolic disease, fasting insulin, fasting glucose, for example, fasting triglycerides. But also of interest to my lab, we're very interested in the immune system and how microbes can interact with the immune system. and fermented food intake is associated with lower levels of inflammatory markers in the blood.
So for that
yeah.
data, is the NHANES data specific to live cultured containing fermented foods?
It is.
Okay.
It is specific to live culture foods, which is suggestive that you need perhaps the active fermentation within a food is important, and that those cultures might also be important themselves. And that's the really tough part about studying fermented food and then the food matrix, is that you have all of these components, kind of interacting together. And then when we consume it, of course, it interacts with our microbiome. We'll talk about all the metabolites that are in it as well. And so it's really hard to study, and I think that's why there hasn't been a lot of controlled studies longitudinally. There has been some work from Jeff Sonnenberg's group at Stanford has looked at if they advise individuals to increase their fermented food intake over a period of about 12 weeks and increase the intake about 3 to 4 fold from their baseline. One of the really interesting findings was in just normal healthy individuals, nobody with disease, they showed a decrease in inflammatory cytokines systemically in the blood, which is a marker of inflammation, in these normally healthy individuals, suggesting that even in healthy individuals, fermented food intake can potentially lower some markers of systemic inflammation. Really, really cool. We just don't know how. And that's something that we're interested in, and a lot of other people are becoming interested in, is why these fermented foods, particularly the lactic acid fermented foods, we think are potentially beneficial for health.
As a Longevity by Design podcast listener, you understand the value of improving your health for today and for all the years ahead. And if you want to live your healthiest, longest life possible, you need to understand what's going on inside. At Inside Tracker, we take a personalized approach to Healthspan optimization that eliminates guesswork from your wellness plan. Inside Tracker analyzes blood biomarker and DNA data, along with physiomarker data from fitness trackers like Oura Ring, to deliver personalized food, supplement, lifestyle, and exercise recommendations that allow you to take control and improve your health span. And for a limited time, Longevity by Design listeners can get 20% off at the Inside Tracker store. So if you're ready to receive a personal health analysis and data-driven wellness plan to optimize your body for the long haul, then it's time to start inside. Visit insidetracker.com/podcast to get started today. That's insidetracker.com/podcast to get started today.
Yeah, and a side note for me about NHANES. So NHANES is a database that created by the US government. They are sampling around 10,000 Americans every year, trying to sample all the population, so trying to be as much as politically correct as possible. There are hundreds of thousands of Americans that already been sampled. I think that started in the 80s, and this is a gold mine for scientists to look and try to understand. They are looking at nutrition, they are looking at activity, doing some exercise, so there is a lot of data, and a good scientist like you are using it. A follow-up question, sounds like from what I'm heard from you, lactic acid-related fermentation is the key. So for our audience, what food come from a lactic acid-related fermentation?
There's a lot.
What are let's say, the top 10? Or?
The top 10. So what's nice about this, I think, is that lactic acid fermentation is possible in a lot of different foods.
Yeah.
So we'll start with dairy. So common dairy lactic acid fermentations are things like yogurt. Now, we have differences in yogurt. We can talk about that. Things like kefir. In the vegetable fermentation realm, we have things like sauerkraut. We have things like kimchi. Within the grain fermentation, we have things like sourdough bread, particularly sourdough bread. What makes it sour is some lactic acid bacteria. But also, as I mentioned, some meat and fish fermentation. So one of those is one of the fish ferments is called surströmming, which is very popular in Sweden and other Norwegian countries as well. So those are some common ones. Did I miss any as far as?
Well, I think if you survey the world, there's many.
There's
in the U.S. we're a little more limited, but there's lots of fun fermented products from like Africa and Asia that involve that have at least a lactic acid bacteria step. Mm-hmm. If not, they're the only ones. And so we're just not familiar with them here because they're not accessible to us. But There's many like sorghum fermented things and many others that are they sound interesting. I don't think I've ever had most of them because they're just not, I don't know how to get them.
Just, and what makes this LAB fermentation, I think, so interesting is, especially with vegetable fermentation, you can get almost any vegetable to be a lactic acid ferment. If you cut it up, put it underwater, and add the right amount of salt and keep it anaerobic, i.e. keep air from touching it, most vegetables will have some lactic acid bacteria naturally on them. We just have to cultivate them. And so it's a really, I think what makes it so cool, it's a simple...
You can do it at home.
You can do it at home, and it doesn't have to be cabbage. Cabbage is the basis
Classic.
for kimchi and sauerkraut.
Yeah.
But, some of the, what we think are beneficial metabolites we found, which we could talk about, were cabbage, they were on cabbage, but we also found them on things like carrots, beets. And so,
Cucumber, I assume.
Yeah, cucumber,
Yeah.
absolutely,
Yeah.
pickles. So there's
Fermented pickles.
fermented pickles.
Yeah.
And
Instead of
different-
brine pickles, but
Yeah.
Yeah, and the key is what I heard from you: 3% salt in water, and that's it. And leave it for how long? What is the right time?
It depends on the
Yeah.
temperature that you
Okay.
have the storage and the there's always a balance with temperature and quality. So the higher temperature is faster, but lower quality perhaps. So it depends on the
If you do it
producer.
at room temp,
Yeah, if you do it at home room temp, it takes a few days.
few days, okay.
But you can. But if you put it in your basement, for example, it's colder, it might take a week or two.
Okay.
You bury it in the ground, in Wisconsin, it might take a month. I mean,
Okay.
just kind of it's a moving target. But what's great is that you, the producer of it, you can. So from one of my classes, the students make fermented products of their choosing. Many choose to make sauerkraut because it's easy. Let me give students credit because they find it fascinating.
Yeah.
Maybe because it's easy. But you can monitor it by tasting it over time. You can tell when it's, you're like, it's not
So it's
sour
okay
enough.
to open and
Yeah, you can
sneak
taste it along the way.
and then close it again.
Yeah, and so you're like, okay, as long as you keep the leaves submerged,
Yeah.
the jar doesn't have to be sealed. In fact, it'd be better because it'll blow up if otherwise. So you want to keep
Keep it open.
it open's fine,
slightly open.
but keep the leaves below the surface because the surface there's very little dissolved oxygen in the brine, so that's good enough. So as long as you don't have anything on the surface, you're good. And you could just go in, grab a fork, scoop some out, try it, and like, not salty enough. Need more time. And you can, as you do it a few times, you'll notice the color change and things like that over time, and you can kind of get a handle on it. But it's totally easy.
You can get a nice sauerkraut in a week, easy.
Yeah.
So it's not a long process at all. And it's a good way, like if you have, we're getting into what you can do. If you have vegetables at the end of the year, if you have a garden, this is a great way to save some vegetables that you can eat over the winter. And that was what it was done a lot.
In my more acidical, but as a faculty member, I always think about ways to get grants and raise money for the research. One of the ideas is always kind of comes up is especially related to food loss. One of the big aspects of food loss is people buy food that they don't consume and it goes bad and then they just throw it away, whether it's milk that's the use by date or vegetables or something. But many of those products they could still ferment them and still do something with it and maintain that product. It's like, if we can get more home fermenters, maybe we would throw away less milk and make more
Cheese.
cottage cheese and yogurt and stuff, and that would be great. But I don't know how that might work for the two of us. I don't know how many other people
Yeah,
are
I think
interested
that
in doing fermentation.
in my opinion, it's education. As you said, it's pretty easy. You save money. You have some health benefits. So what is the negative? And you enjoy the process of making food. So
It is a commitment though. Like I can make my own yogurt easy enough, but I just never do because I can buy yogurt for $1
No, I understand,
at the
but if
store.
I'm talking about vegetable. Usually
vegetables.
we buy too much. Just throw it into the
Some brine,
water
let's go.
solution with a salt and come in a week later and just it's easy. It's not like
It's not hard.
yeah. Cool. So we spoke about the benefits and sounds like amazing. So and it sounds like we don't know yet what is the reason why the fermented food is providing so much benefit. And one of the benefit that you mentioned was basically inflammation. Is it also systemic inflammation or is it just a acute one?
No, I think it is systemic. I mean, that's what some of what we have as far as longitudinal work is showing us, is that we see this reduction in systemic, i.e. these inflammatory molecules that are circulating in the blood, which would be the definition of systemic inflammation. Now, how it does that, right? We have no idea. And I think there's probably a lot that we know there is a lot to learn as to what these microbes and the molecules that they produce, what they're actually doing to the immune cells and how they're signaling to the immune cells to mitigate this long-term, what we call chronic inflammation that underlies a lot of inflammatory and metabolic diseases. And so, that's kind of broad strokes. We think that there's some, if you consume these foods for a period of time, there could be a drop in systemic inflammation, but a lot that we need to learn, in the in-between, what's actually going on with the immune system that's highly complex, and there's a lot of moving parts.
And it sounds like the two of you are trying to find and understand why.
Well, I think for the people to understand, if we know, the more we learn about the mechanism, the more that we can take advantage of the process. Yeah. Right now, it's just like, well, live culture and fermented food. That's good. Does it matter which cultures are there? Nah. Does it matter? Is it like understanding the mechanism provides the ability to provide very specific advice to consumers, very specific advice to producers to maximize these kinds of activities of the product. Yeah. So it's not just some trivial scientist trying to figure out mechanism. This actually has, I think we do this because it has impact on people's exposure or just relationship with these food items. We can actually really have a dramatic change by understanding mechanism.
Yeah, I assume that you want to build a more potent fermented food for a specific indication, and also know, do you need to eat one cucumber or two cucumber, and so on and so forth. So it makes a lot of sense to try to understand it better. Now we have high level, let's deep dive and understand it better. And this podcast is Longevity by Design, so I have to ask you a question about that. So what is, if at all, what do we know about the effect of fermented food and longevity? Is there any information about
Well, I could just anecdotal. I'll start with the anecdotal part. Maybe Jacob has more size. I have an anecdotal story. The very first person who really kind of started the probiotics field was Meshnikov.
So it's a Russian guy?
He realized people in Bulgaria and that part of the world lived longer because they ate more fermented things. And that these particular bacteria were going to be responsible. He actually was a Nobel Prize winner related to innate immunity discoveries that unrelated, at least not directly related to this commentary, but he was kind of the father of probiotics and had this idea that people lived longer because they ate these fermented dairy products, 100 plus years ago. But
and he wasn't necessarily wrong either. I just think he didn't have all the evidence to put together, and we still don't. But kind of a contemporary piece of evidence of that is a correlation, not a causation, quite yet. But I always, when I give my presentations on fermented foods, our kind of ongoing experiment, this large ongoing experiment, in my opinion, is in a particular country, which is South Korea. Where we have individuals consuming very high amounts of fermented foods. So an average South Korean is estimated they consume about 37 kilograms, so close to 100 pounds of kimchi a year. Wow. And why that's interesting is that in 2030, the expected life expectancy of South Koreans is expected to exceed any other country in the world. Both males at over 85 years, and females at over 90 years old. So this country, South Korea, of course, there's a lot of other things that could potentially be going on here, but it is very interesting that these individuals consume high amounts of fermented foods in the case of kimchi, and they do have this long life expectancy. Of course, that's just, there's no evidence in between that. It's something. It's a correlation, but something that I think gives credence to what Meshnikov really honed in on early in the 1900s, which was this relationship with Bulgarian long life as well. So
I assume that it will be interesting. I'm putting my scientist hat to compare the Korean in Korea versus the Korean here in the US. I assume that they are consuming less and see whether there is a correlation between. But anyway, that's for a different discussion. And today there is a lot of a buzzword about, we discussed probiotic, prebiotic, and now there is something called postbiotics.
Yeah.
So can one of you explain what does it mean, postbiotics?
well, this is the newest out of the three terms. So we talked a lot about probiotics, so these are the live microorganisms that exert a health benefit. The regulation agencies have also defined prebiotics really well. So these are essentially the substrates that feed into the microorganisms, so what they eat up basically. The postbiotics, and this is still being, teased out as far what is the true definition of a postbiotic. And I think there is, Mike can correct me, there is starting to become a more defined definition, but these are products that are released by the bacteria. This can be either been in food or potentially in, just probiotics themselves that are released that may exert some bioactivity that would benefit the health of humans. The issue with postbiotics is the research is still very early on, and we don't have a really defined definition and a lot of evidence as to which postbiotics exert these health benefits and what they actually entail. And so
there's many products in the postbiotic, so even showing that the postbiotic does something is interesting. But then, like, what part of the postbiotic should we is doing the business that we're measuring? And so I think there's a lot of undiscovered territory in that space. But as people have started to realize that these bacterial metabolites are interesting. I mean, many of the circulating metabolites people can measure in your blood are bacterial from bacterial origin.
Yeah.
And so some of these things can be very important and have very bioactive functions, or have high bioactivity. And so identifying them, why are they there, which foods have more, which ones have less, can we manipulate how much they have, can be very impactful on the health benefits of various fermented foods.
Absolutely. Anything that you guys discovered related to postbiotics that we should know?
Yeah, we think so. We think so.
That's why we're here, Gil.
Yeah, we think so. So, just to touch on a little bit of what we're working on, we've, for a variety of reasons, have become interested in a certain subset of metabolites. I'm not ready to call them postbiotics yet, because we have to show some health benefits. We think that they're there, but we got to really prove it. But essentially, they're related to lactate in a way, which I talk about these bacteria that spit out lactate, which these lactic acid bacteria that are in our fermented foods. But they also metabolize other molecules like amino acids. And the particular amino acids that we're focused on are what we call aromatic amino acids, which are phenylalanine, tyrosine, and tryptophan. And what we've found out is that the bacteria within fermented foods can metabolize these aromatic amino acids into downstream metabolites. And there's a bunch of different downstream metabolites that they can turn into, but one of them that we're focused in on are what we call aryl lactates. So they have this lactate moiety, but they also have this aromatic part of them too. And there's 3 different ones that we're focused in on, downstream of the phenylalanine, downstream of the tyrosine, and downstream of the tryptophan, that we think are potentially beneficial. But what's really interesting is we think all 3 might be beneficial in different ways. And so we're trying to figure out, what are the interactions with our cells with these metabolites, or what we call our postbiotics. Yeah. And we have some evidence that they are binding receptors on immune cells. One of the receptors is what we call aryl hydrocarbon receptor. And why we think this is relevant is that there's some emerging data that the ability to bind this receptor by microbes in our gut, so the metabolites they produce, is lower in chronic inflammatory diseases like inflammatory bowel diseases and obesity. And so we think that we can find these metabolites within fermented foods. And we think that if we can actually augment the levels of these metabolites, in particular metabolites that activate the aryl hydrocarbon receptor, we might be able to mitigate some of the depletion in our natural microbiome to activate this really important immune receptor that we think might be able to mitigate some of the problems associated with those diseases. So that's kind of our big picture.
Yeah,
long-term goal,
very
if
interesting.
that makes any sense.
Very interesting and exciting. So I assume that if I'm taking it one step further, it might be good for obese people and people with systemic inflammation to eat more fermented food in order to have more of those metabolites and basically decrease inflammation. That's fair to say?
We think so. We think so. We want to put, we're scientists, so we have to show, we want to show everything, right?
Yeah.
Right now, we have evidence that these metabolites are in foods, and that if we change the levels of these metabolites, we can actually increase the bioactivity of the food.
Yeah.
So we can show when we take mash the food up in an artificial stomacher and stick it on these cells that report activity of a receptor, we can do that. We could change what the food is doing to the immune system, but this immune system in a dish.
Yeah.
Now we need to take it and try to understand what's going on in humans, which is people are a lot more complicated. There's a lot of things we need to figure out. So I'd say there's a lot of potential, but we got to, as scientists, we always have to show the evidence to really give a strong recommendation.
So you have some data in the model organism, or it's more in the cells right now?
It's cells, and we do have some data in preclinical data that we're working on currently. Not ready for prime time yet, but we'll put it this way: we think that there's a lot of opportunity.
I think it's always, maybe the audience doesn't realize this, but as scientists, we're always pretty cautious with our conclusions, so we always kind of only go as far as we can demonstrate, and so we are going down that path. But I think that's what's going to be coming. If you check in with us in 5-10 years, we'll be able to say a lot more about the human impacts.
Yeah.
But another aspect that Jacob mentioned was that the fermented foods that we went and did our two groups went and did a massive search of products in the community from different grocery stores and measured these compounds in various yogurts, Greek yogurts, kefirs, kimchi, sauerkrauts, salamis, and all sorts of things. And what was funny is that some of these products are higher, some are lower, but they're all present. They all have them. They're varying amounts. Some yogurts have higher amounts. Some yogurts are lower. Some Greeks are higher. Some Greek yogurts are lower. Some kefirs were actually variable as well. And so it's interesting to think about what the food industry could do to maybe make so that all the Greek yogurts are higher instead of just some of them. And I think part of this is because this is so new that they're not thinking about this. Yeah. And they're not selecting cultures that make these as part of their selection criteria. So not all lactase bacteria make these metabolites that Dr. Allen and I are interested in. And so identifying those, identifying conditions where they make the most, and then exploiting that in products so that then demonstrating that there's a health benefit when they're consumed by people. I think I think at least I'm kind of getting to my future talk here, but I think that's what I see is what's going to happen in the future.
No, makes a lot of sense, and it sounds like you see it more as a food additive. Then I can come say maybe it can be a supplement or maybe it can be a drug, but you naturally see it as
I very much think about it from a whole food perspective, and so we are definitely trying to think about food fermentations in a way to optimize these compounds that we think are bioactive. Yeah. And demonstrate that there's a health benefit from that optimization that we're doing.
Makes sense.
Yep.
And that was a fascinating discussion. I haven't knew a lot about fermentation, and now I feel like I know
hungry
something.
Baby. Yeah.
Made me hungry for sourdough. Every time that we are interviewing a scientist, we are asking them to provide to our audience a tip about longevity. It can be about fermentation. It doesn't have to be.
Yeah.
So maybe we'll start with you, Mike. What is your...
Wow. Well, if I wanted, I think one thing that a good life skill for anybody to have would be able to make yogurt themselves or make sauerkraut themselves. It's stunning how many of my students in my class have never fermented anything before. And then afterwards, they're just like, wow, that was so easy. And it was so great. I can't believe I've never done this before.
Yeah.
And I think having that experience and I think further, just if nothing else, that increase science literacy amongst the population. People have a better appreciation for microbiology, which, I think is great. But I think there's health benefits as well. But I think just being more aware of your food, how it's made, I think is also a good
I
thing.
think that it's fun, it's cool, it saves money because you don't throw your vegetable to the garbage.
Yeah, and I think if you have young kids, maybe they'll be more interested
them,
in
it's
trying
fun,
it because it's fun and they're involved in the process. So I think there's a lot of advantages to
and most likely it's
entering
good
that
for
space.
you,
Yeah. So I think, that'd be my suggestion.
What about you, Jacob?
And just that there's also a lot of flavor that you can change with fermentation too. So there's a lot of art to it as well. So you can bring in, if people like to cook, I think they would love to ferment.
Yeah.
Because you can change things up. You can add little things to the ferments to change the flavor slightly.
What can you add? Can you give us an example?
Yeah, this is an alcohol fermentation, which I still like to do that too. But I made some mead over the winter, which is essentially a honey ferment. So if you get raw honey and you add water to that honey, and again, keep it anaerobic, that honey will ferment. And what I did was added a lot of different fruits and different herbs to the mead, and I did different batches of it, and each one tasted completely different. And so you can have fun with things like that.
Yeah.
In this case, it was mead for this example, but you can do this with vegetable fermentations as well.
Kimchi is so variable.
So variable, yeah.
Every family makes kimchi their own way in South Korea.
Yep.
And they all have very strong opinions about this, is my experience. So,
Yeah.
But they get very different. Some are spicy, some are not. Some have, turnips, some don't included in it. It's a very variable situation, so it's totally made to their taste.
Once you get the basics down, you can change up a lot.
Yeah.
It makes it fun, I think.
Yeah. No, it sounds like that. And again, thank you so much for enlightening us about fermentation. And I think that we are coming on time. So thank you so much, Dr. Allen and Dr. Miller. We look forward to exploring the research in the field of longevity each month with you and the leading scientists. For more information, please go to insidetracker.com/podcast.
Thanks for listening to Longevity by Design. Please subscribe to this podcast on Apple, Spotify, or YouTube. Longevity by Design is powered by Inside Tracker, a personalized health optimization platform that helps people improve their lives by improving their bodies from the inside out using personalized, science-backed recommendations for nutrition, supplements, and lifestyle changes. To learn more, visit insidetracker.com/podcast.